Hello, let's continue our Sudoku adventure with Looking Inward by Matt Tressel. So this is a shading puzzle in addition to being Sudoku. I'm going to go over what all that means. So we have normal 6x6 Sudoku rules. That means in each row, each column, in each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have shaded rooms. So any digit on the border is going to point at a shaded cell. So what do I mean by point at? Well, it's counting. So let's say this was a 3. We starting from this border, we go 1, 2, 3. This must be shaded. I'm going to use gray for shaded. I'm going to use green for unshaded. So if this was a 4, we count 1, 2, 3, 4, and this would be shaded. If it was a 1, then it's saying itself is shaded. That's from any border. So if this was, say, a 4, then we count 1, 2, 3, 4, and this would be shaded. All right, so hopefully that's clear. Now, no two shaded cells may share an edge. So we can't shade both of these because they share an edge. So next to a shaded cell, the ones that share an edge must all be unshaded. You can mark that green. Could be helpful. Diamonds are always not shaded, so we can just mark those green. And the digit inside counts the number of shaded cells. Orthogonal neighbors, sorry, the shaded orthogonal neighbors. So orthogonal neighbors are neighbors that share an edge. So if this was a 3, for example, I'm just going to do an example that's not possible because there's a 3 there. Then all 3 of these would be shaded because this one's not. If we made, I don't know if we have, let's say we made this one a 2, then we could do, say, these 2 shaded and this one unshaded. That would be one way to fulfill it. And that has a count of 2 shaded cells around it. All right, hopefully those rules are clear. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so I'm going to start by greening all of these, and I'm going to fill just the maximum neighbors in here. So this can have 1 or 2 neighbors that are shaded. This can have up to 3 shaded neighbors. This can have only up to 2 shaded neighbors. This can have up to 3, but the 3 in the column tells us it's actually up to 2, and this can have up to 3. Okay. So 1, 2, or 3 tells us that one of these 3 must be shaded. Now, it's not this one, so it's not 1. So 2 would put a shaded cell here. 3 would put a shaded cell here. Okay, but a 3 would also put a shaded cell here, right? Because a 3 would force all 3 of these to be shaded. But the 3 also forces that to be shaded by the shaded rooms rule. And so that puts 2 shaded cells sharing an edge. So that doesn't work. So this is a 2, still unshaded. That's a 1, that's a 2. Nice. Now this 2 does put a shaded cell right here. Okay. Which means that I can green around it. And now it's clear that this has to be the 1, so that's shaded. Okay. This 2 has to shade both of these. So let's surround all of those with green. Ta-da. All right. This 2's there. Okay, I haven't gotten any other edges. This says, okay, this can't be a 1. For the same reason this couldn't be a 1. It would make itself shaded, but we know it's not shaded. So that's a 2, and that puts shadeds in both of these. That means that's unshaded because it's next to the shaded cell. Okay. It may be fruitful to think about the edges that we know, think about the rows and columns that we know a lot about in terms of shading. So like this row here, it itself could be shaded, or 3 or 6, but that's it. This cell here it can't even be itself because it can't be a 1. So this actually must be a 5. It's the only shaded cell it can point to, so it must. Here, this could be a 1 or a 3. That's actually a 1-3 pair. So let's just put 4, 5, 6 in here. Why not? Here, itself could be, oh no, 1 is used. So it can't be itself, it can't be pointing to itself at least. It could be a 2. Or it could be a 5. All right. This could be itself or 3. No, not 3. 3's in the box. Or 6. So 1 or 6. All right. Any others? This one here could be itself, could be 3, or could be 5. Is there more to any of these diamonds? I know one of these is shaded and the other is not. Huh. How about here? This can be 1. It can't be a 2 because of the row, the 2 in the row. 3, 4, so it could be 1 or 5. Oh, it can't be 5 either. Okay, so this must be 1, and that shades this one, which unshades these 2. Oops, wrong color. Shades those 2. And so now this one here can't be 1 or 2. So it could be 4 or 6, pointing at one of these two. 1 and 2 already in the column. This might be interesting. In fact, we're down to 3, 4, 6 here. It's not a 3, so that's a 4, 6 pair. Now, but 4 doesn't actually work because that's green already. So 6 makes that shaded, makes this a 4, which makes this shaded and this shaded. So we can surround all of these with unshaded cells. Same with this one. And I think we're pretty close to being fully shaded here. 1 says itself is shaded. That makes this a 3, which is pointing at that one. All right, this is 1. Oh yeah, we kind of knew the count at some point. All right, that's 3. I think there was always something to do, so I'm not too worried about having missed that for a little bit. All right, this is 2 or 5. Let's see. I should be able to use a lot of these. Is there anything I missed? I got so much at once. 1, 3, 5. Okay, what am I missing then? This has its 2 shaded, so this is unshaded. Oh, and this is unshaded because it's next to the gray. Okay. So the question is this shaded or unshaded? I'm not sure yet. I get the feeling this is going to be a 2 to make that shaded, but we'll see. Let's just do Sudoku. There's probably a lot of Sudoku to do. Choosing one of these two. Here we just need 2, 3, 5, or sorry, 2, 5, 6. That's not the 2. So this is pointing at 5 or 6, but 6 is not shaded, so it has to point at 5. Gives us the 4 and the 2. Yep, that ends up a 2, making that shaded. That was probably the only way to resolve that one, although maybe this one would have. Anyway, that's 6, that's 2, that's 5. That's not 5, these are not 4. This is a 1, that's 3. All right, these 2 digits are the 4 and the 6. That probably is resolved. Yeah, this has to be the 4 to point at that shaded cell there. This 6 points at that shaded cell. That's a 5, that's 6. Sudoku probably finishes this. That's 1, that's 4. 3 and 5 here, that's 5, that's 3. Okay, that points correctly. Here we need a 4 and a 5. That's, oopsie, that's 4, that's 5. Just misclick there. We need a 2 and a 6. That's 6, that's 2. Here's a 3, and then we need 4 and 6. All right. Interesting puzzle, Matt. I hadn't seen that constraint before. But yeah, it's an interesting. I always like when there's an extra layer of solving to do. In this case, the shading. Cool. And we ended up with no 2 shaded cells touching. That's good. I'm not going to go through the whole border, but I think we kind of double checked most of it anyway. All right. Well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.